So good evening. Here we are again, more word problems. There's one kind of word problem left to do. This is called a motion problem. What happens when I throw something into the air, when it goes up and comes down? This shape of throwing something up in the air is a parabola. So these motion problems have a special setup. Let's look at this. We are on course packet, page 522. Course packet page 522. Vertical motion problems. This is exactly what you have in front of you. You can take your notes on this page. When an object is thrown up vertically, with an initial velocity in feet per second is important. The formula describes, which describes this is h, your height, is equal to negative 16t squared plus vt plus s. H is the height of the object at time t. So depending on the time, that's where the height of the object is. T is the number of seconds, amount of time since it is thrown. V is the initial velocity of the object. S is the initial height from which the object is thrown. The only other difference is some of these will also be done in meters. So I have a second equation. The initial velocity in meters is h height is equal to negative 4.9 t squared plus vt plus s. Again, v is velocity, s is the initial height, t is time, h is the height at time t. And notice my number, instead of negative 16, I have negative 4.9. This is meters instead of feet. So let's try an example of this. A baton twirler is 5 feet tall. She throws a flaming baton with an initial upward velocity of 60 feet per second. Write the equation representing this problem. Well, again, I'm going to start with h is equal to negative 16t squared plus vt plus s. Plug in what I know. I don't know the initial height. That stays h. The negative 16 stays the same. The time I don't know, so that stays t. My initial velocity is 65 feet per second. So my v is 65, t stays the same. And my initial height, the height of the object, when it is thrown, is 5 feet, the height of the person throwing the object. That's my equation. H is equal to negative 16t squared plus 65t plus 5. The thing about this, though, is I don't have h's and t's in my calculator. I want to put this in my calculator. So h is going to be y, probably y1. Let's try that again. Negative 16, instead of t squared, we're going to do x squared plus 65. Instead of t, we're going to do x plus 5. This is what I'm going to put in my calculator. So let's pull up my calculator and let's look at that since we will be using our calculator. I'm going to go to y equals, and I'm going to plug in y1 negative, not minus, but negative 16x squared plus 65x plus 5. So there's my equation in the calculator. I want to think about what I want this to look like. You know, I start at 5 feet. I'm going to go up high. So let me fix my window now. You know, I'm dealing with seconds, and as I throw something up in the air, think about it. It doesn't stay in the air very long. X is time. So I'm going to start with negative 2 just so that I have space. I can see the y-axis. My x max, I don't know how much time I'm going to be in the air, but let's count about 8 seconds, okay? X scale, how do I want to count? I'm going to count this in 0.5, half seconds. Let's look at my y. This is the height that I'm going up into the air. Again, I want a negative number in my y minimum just so that I can see the axis. My x max, well, how high am I going to be throwing this? I know I start at 5 and it goes up. I'm going to go ahead and guess 80. And let's see what this looks like. If I go ahead and graph this, there's my data. There's my graph. That's a good graph. I'm going to shrink it just a little bit on the x. Instead of going to 8, let's go to 5. And that shows my full graph. That's a good picture of it. I'm going to fix my y real quick. Instead of counting my y scale by 1s, let's go ahead and count this by 10s, so it looks a little neater. So that's what my graph is going to look like, and we'll be working with the graph later, but at least I know I can see the graph well. So let's look at my question. Letter B asks us, when, that's the key word there, when will the baton be at its highest point? I'm going to scroll down a little bit so we can see this. When will the baton be at its highest point? Highest point is key. Let's not do that in blue. Let's do that in red. Highest point, when? So I'm looking for the time when I'm at my highest point. That's my maximum. So this is just like maximizing the problems that we've been doing. What is my time when I get to my highest point? So I'm going to bring up my calculator again. I want to find my maximum, and if I look at the graph, remember my maximum is that vertex right up there. I want to know what that time is. So time, again, remember, is going to be x. So it's going to be somewhere in here is going to be my time. I'm going to use the calculator to find this. So I want a maximum. So I'm going to hit second trace to go to the calc. I want maximum number 4, so I'm going to scroll down to number 4. Left bound, I am to the left of my vertex, so I'm going to hit enter. Right bound, I'm going to tap over till I'm to the right of my vertex. I'm going to hit enter. Guess, I'm going to tap to the middle of those two markings, there and there. So I hit enter, and I get a maximum of 2.03. So I'm going to go ahead and slide this over here, and I now have this maximum point. I know that time is x, so I'm sitting at, my time x is t, which is 2.03 seconds. That's where I got it from that equation. Oh, wrong place. Let's go ahead and put it up here in B. X is my time t, which is 2.03 seconds. How high is its highest point? There was a reason why I dragged this over here, because I also have my y. My y is height h, so my y is my height, and my height for this is 71.02 feet. I get both of these answers off the same slide, off the same picture in my calculator. I have a maximum height. I have the time for the maximum. At the same time, I have the maximum height. And I'm able to read both of those, answer both of those questions. Let's go on to question D. When will the baton be back at the twirler's height? Well, what is the twirler's height? We know that the twirler started off at 5 feet. So I want to know when I'm back at 5 feet. If I bring up my calculator again, we can see that right here I have my y-intercept, and I want to know when I'm back at that same height of 5 feet. Well, that looks like a horizontal line. So that tells me height is h. So my height, which we're using as y, needs to be 5. So I'm going to go to y2 in my calculator. I'm going to hit y equals, go to y2, and I want my height to be 5 feet. So I'm going to hit enter, and I'm going to hit graph. Sliding this over here, I already know that this is time 0. I want this intersection point. I want time is question mark. I'm still at 5 feet, so that's what I want to find. So I'm going to hit second trace to go to the calc button. I want intersection number 5. I'm going to hit enter. My first curve is the parabola, so I'm going to hit enter. My second curve is the line, y equals 5, so I'm going to hit enter. My guess, I need to arrow my guess over till I am closer to this point than to this original point. I have to be closer to this new point. As long as I'm past the vertex here on the x, I'm fine with finding this, but I'm going to scoot all the way over just because I can. And I'm going to hit enter for my guess. And I see that I am at 5 feet high. My time is 4.0625 seconds. So when will the baton be back at the twirler's height? That's going to be, x is going to be 4.0625 seconds. So I figured out the maximum, the time of the maximum, and the actual height of the maximum. When the height got packed to where the twirler threw it up from, I got that height. What does E say? Well, E says if the twirler misses the baton, at what time will it hit the ground? Well, hitting the ground, what's that? Hitting the ground is when I'm at height 0. So I want my y, or my y2, instead of being 5 feet, I want it to be 0 feet. I can technically choose the height to be anything I want and find what that height is, but right now I want height to be 0. So I'm going to go back to my calculator. I'm going to hit y equals. I'm going to change y2 from 5 to 0. I'm going to graph this again. And I don't see that second line. Realize that second line, 0, is the x-axis going back and forth right here. So I'm still going to do second trace to go to calc. I want number 5, intersection point. I'm going to hit enter. First curve is going to be the parabola. Second curve is going to be the x-axis, y equals 2, or y2 equals 0. Now I need my guess. Again, my guess needs to be closer to this point than my initial point. So I'm going to arrow over close to this new point to see when it hits the ground and hit enter. And I get the baton hits the ground. Hits the ground is when y is 0. The baton hits the ground at 4.14 seconds. 4.14 seconds. That's when it's going to hit the ground after it went up. It got to its maximum of 71 feet. It came down at 5 feet. It had taken 4.06 seconds. Now it hits the ground at 4.14 seconds. So let's go ahead and do letter F. Letter F says, okay, sketch the graph and label each of the above points on the graph. So here's my graph. My parabola starts outside 5, 10, 15, 20, 25. So it's going to cross the y-axis at 5. It's going to go up. I'm going to stop for a second, and I'm going to do it a little differently. I know that I'm going to cross the y-axis at 5 seconds, so I need that point. I know that it's going to reach my maximum at 2.03, a maximum of 71 feet. So around 2 seconds, I need to be close to 71 feet, which is about right there. Coming back down at 4.06 seconds, I need to be back at 5 feet. And at 4.14 seconds, I need to be back on the ground. Those are the points that I want to hit. So I'm going to go ahead and draw my parabola. I'm going to go through my initial height, go through my maximum, and I'm going to come back down through these 2 points. My initial height I know was the 0.05. My maximum I know was 2.03, 71.02. I then have 2 points down here, 4.06 and 5 feet. And my last point was 4.14 and 0 feet. There are my points on my graph. I drew my graph, my parabola. It was a negative parabola, so it should be facing down. I should have a maximum. Lastly, how high is the baton after 1 second? After 1.5 seconds. So this is letter G. For letter G, let's go ahead and bring up our calculator once again. I want to know when the baton is at 1 second and 1.5 seconds. I could go to the table button right here, hit second table. But what I'm going to choose to do is, again, is go back to count. I'm going to hit second trace to go to count. I'm going to plug in one value. X is time. Since I want 1 second, I want the time. So I want my X to be 1 and my X to be 1.5. And I want to find the Y that goes with that. But remember, this is time and this is height. So I want to find the heights that go with these times. So bringing up the calculator again, X equals 1. I'm going to hit enter. The time is 1. What's my height? My height is 54 feet. Number 2, how about 1.5 seconds? So I'm going to again hit second trace to go to count. I want number 1 for value. I want 1.5 seconds. So I'm going to hit enter. And the height at 1.5 seconds is 66.5 feet. I got all this information from my calculator. When I put the equation correctly into the calculator, we're through, we're done. Mr. Lovell, sit up straight, stop drooling, just joking. Ty, good to see you. Here we go. Have a good day.